How does a civilian's design, built in just 48 desperate hours, save the advance of General George S. Patton's mighty Third Army? This is not a tale from a textbook, but a frantic, muddy, and ingenious race against time in the late summer of 1944. The location, the Meuse River, near the French town of Commercy. The problem, a furious Allied advance had outrun its own supply lines, and a critical river crossing stood incomplete. The solution would not come from a manual, but from the mind of a civilian engineer thrust into the heart of war. By late August 1944, General Patton's Third Army was a scythe, cutting through the German defenses in France. After the breakout from Normandy, his armored columns moved with breathtaking speed, a doctrine of relentless advance he called audacity. But this very success created a crisis. The rapid advance stretched supply lines to the breaking point. Fuel was rationed by the gallon and ammunition was scarce. Yet the order was to keep moving, to prevent the shattered German forces from regrouping. A key objective was crossing the Meuse River, a major natural barrier. Existing bridges had been demolished by retreating German forces or were hopelessly congested. The U.S. Army Corps of Engineers, the unsung heroes of the advance, were tasked with building new crossings under constant pressure. Their standard floating Bailey bridges were magnificent. But they took time Patton believed he did not have. Into this high-pressure situation stepped a man named John P. Jack Decker. He was not a soldier by trade, but a civilian engineer and bridge designer from Chicago, now serving as a lieutenant colonel in the Corps of Engineers. He carried in his mind a radical, unproven concept, a bridge built not from the bank out, but from the middle of the river. On August 29th, the situation at the Meuse reached a critical point. Elements of the 5th Infantry Division and 7th Armored Division were piling up on the western bank, their vehicles idle, vulnerable to Luftwaffe strafing runs and distant artillery. Every hour stalled was an hour for the Germans to dig in on the far side. The commanding officer of the 1103rd Engineer Combat Group, Colonel John T. O'Neill, was given an impossible deadline: get a crossing operational now. Standard construction was bogged down by the swift current and the need for extensive groundwork. That's when Jack Decker approached. O'Neill with his idea, the Decker Double-Double Bridge. The design was unorthodox. It called for constructing 2 standard floating treadway bridges, but instead of launching them from the shore, they would be built separately on rafts in the middle of the river, then floated into position and connected to the banks. On paper, it promised a cut construction time in half by bypassing the most difficult shoreline work. But this was not paper. This was a fast-moving river under potential enemy observation. The materials were the same: floating pneumatic floats, steel treadways, wooden decking, but the method was a gamble. Colonel O'Neill, facing no good options, gave the green light. The clock started at 1600 hours on August 29th. The initial construction was a scene of organized chaos. Engineers, exhausted from weeks of constant movement and labor, worked in the chilly river water, assembling the crucial central rafts. The roar of bulldozers and the clanging of steel filled the air. Night fell and work continued under the glare of generator-powered lights, making them a potential target. The pressure was immense. Upstream, other units were attempting their own crossings with heavy losses from accidents and enemy fire. Reports filtered in of traffic jams stretching back for miles, thousands of men and vehicles waiting on the whim of the river. For Patton's advance to maintain its momentum, this bridge had to hold. If Decker's theoretical design failed in practice, it would mean days of delay, a logistical catastrophe that could blunt the entire Third Army spearhead. The weight of that potential failure rested on the shoulders of the shivering engineers in the Meuse. Then the innovation of Decker's design began to pay off. By building the central spans independently, the engineers avoided the treacherous, muddy riverbanks that had slowed other projects. As dawn broke on August 30th, the 2 separate floating sections were taking shape. The real test came in the assembly. With meticulous coordination, the pre-built sections were maneuvered into the current. Tugboats and brute manpower guided them into alignment. The critical moment arrived, connecting the floating center to the fixed abutments on shore. Engineers, balanced precariously, secured the vital pins and bolts under the strain of the river's push. Against all odds, the theory translated to reality. The connections held, By the afternoon of August 30th, just over 24 hours after work began, the first cautious test vehicle, a Jeep, rolled across the creaking, bouncing span. It held. Then a truck. It held firm. The Decker Bridge was operational. What happened next was a flood of American might, a continuous stream of 2.5-ton trucks. Tanks on tank retrievers and troop carriers began rolling eastward, their wheels drumming a steady rhythm of renewal on the steel treadway. The logistical logjam was broken. The lifeline was restored. The final construction time for the 280-foot Decker double-double bridge was approximately 48 hours, half the time of a standard bridge in those conditions. For the next week, it served as a vital artery, with over 10,000 vehicles crossing its span, delivering the fuel, ammunition, and reinforcements that allowed Patton's Third Army to continue its drive toward the German border and the Siegfried Line. The bridge itself became a legend within the Engineer Corps, a testament to adaptive thinking under fire. The human cost at Commercy was light compared to the brutal combat elsewhere, but the engineering feat saved countless lives that would have been lost in a stalled, vulnerable offensive. For his ingenuity, Lieutenant Colonel John Jack Decker was awarded the Legion of Merit. His citation read, "In part for exceptionally meritorious conduct, by designing and constructing an unusual type of bridge which saved approximately 3 days' time, more than a medal." His legacy was a lesson in flexibility. In a war dominated by industrial might, this moment proved that a single innovative idea, executed with courage and skill, could change the tempo of an entire army.